Hello, welcome to this video on special right triangles. So we've been talking about Pythagorean theorem in the last video, right? A squared plus b squared equals c squared. And we talked about right triangles. During triangle congruency, during Pythagorean theorem, things like that. Now we're going to talk about two special right triangles. We call them special because their angles are most commonly used in trigonometry. So we're going to talk about 45, 45, 90. And we're going to talk about a 30, 60, 90. I don't have that drawn up yet because that's going to come next. So 45, 45, 90. Now remember on a 45, 45, 90, these two base angles are the same. Right? They're congruent. Base angle theorem, that means opposite sides are congruent. So this is an isosceles triangle. So the two legs here are equal in measure, equal in length, and then we have a hypotenuse. We're going to find a pattern today. Instead of having to use the Pythagorean theorem, we're going to find a pattern to find these side lengths really, really quickly. And next year, you're going to use that pattern to develop your trigonometry. So here we got a table here with different triangles. We have 5 different triangles, and we have their side lengths. We have A, B, C, and then because we have Pythagorean theorem, we have A squared, B squared, and C squared, right? A squared plus B squared equals C squared. We're just going to start filling this out. So here's side A. Here we'll say this is A, we'll say this is B, and the hypotenuse is always C. So side A and side B are equal because it's 45, 45, 90. Right? The two angles are congruent. That means the opposite sides are congruent. So they're equal. A squared, so 5 squared is 25. B squared, 25. To find C squared, 25 plus 25 is 50. Right? A squared plus B squared equals C squared. And then to find C, we take the square root of 50. Square root of 50. Right? C squared equals 50. Let's do this. C squared equals 50. To undo the square, we square root. So C equals the square root of 50. Now we're not done. You have to simplify. Okay, you have to simplify. So let's see. 50, we can go 2 and 25. 25 is 5 and 5. There's a group of 2 with a 2 left over. So 1 5 comes outside, and the 2 is left over inside. So this is 5 square root of 2. Let's try here. If B is 11, A also has to be 11. Right? Because we have a 45, 45, 90, so opposite sides are equal or congruent. So if A and B are equal, A squared and B squared are equal, so this is 121. Let's see here. 121 plus 121 is 242. We want the square root of 242 to find C. There's a group of 2 of the same with the 2 left over, so 11 square root of 2. Let's see, here A is 7, so A squared is 49. Since A is 7, B also has to be 7. B squared is 49. 49 plus 49 is 98. B here is 2 square root of 3, so A also has to be 2 square root of 3. A squared is 2 square root of 3 squared. The square applies to everything. So 2 squared is 4. Square root of 3 squared, right? The square root and the square undo each other. So 4 times 3 is 12. So this is 12. This also has to be 12. Now we take the square root of 24. Square root of 24 to find C, right? C squared is 24. Take the square root to find C. 2 and 12. 2 and 6. 2 and 3. There's a group of 2 of the same numbers. A 2 and a 3 are left over. So 1, 2 comes outside. 2 and a 3 left over inside. So 2 squared is 6. And this last one here, if A is 4 square root of 2, then B has to be 4 square root of 2. A squared is 4 square root of 2 squared. So 4 squared is 16. Square root of 2 squared. The square and the square root undo each other. So 16 times 2, 32. 32 plus 32 64. Okay, there's our table filled out. Now let's look for a pattern. So 45, 45, 90. This side's A, this side's B, this side's C. Well, with A and B, A is always equal to B with a 45, 45, 90. So let's just assume that A is some side length. We'll say it's X. A is X. That means the side B also has to be X because they're equal to each other. Well, we just got to find the hypotenuse. Look, A and B is 5. Hypotenuse is 5 square root of 2. A and B is 11. Hypotenuse is 11 square root of 2. A and B is 7. The hypotenuse is 7 square root of 2. A and B is 2 square root of 3. If I multiply by square root of 2, 3 times 2 is 6. 4 square root of 2 times square root of 2 is 4 square root of 4. Square root of 4 is 2. 4 times 2 is 8. So the hypotenuse for a 45, 45, 90 is you take a leg and you multiply by the square root of 2. And that's your pattern. Make sure you have this written down, this pattern. Okay, this pattern is extremely important. It sets up everything else we're doing. Now, I know there's some practice problems here. What we're going to do is we're going to find the pattern for 30, 60, 90, and then go through the practice problems because I don't want to erase the whole table and remake it, so I'm just going to erase the values inside it. So now we're going to skip over to the second page. We're going to look at the 30, 60, 90 triangle and find its pattern. So here's 30, 60, 90. So this is 30, 60, 90. Now, so the side across from 30 is going to be A. The side across from 60 is B. And hypotenuse is obviously C. Now, A and B are not equal anymore because 60 is not equal to 30. So let's see here. Let's erase some stuff. You can skip forward if you haven't already. Or maybe you like watching me erase things. Okay, and then let's put in, we have one less row. So we're not going to need this row. Let's see, this is 6 square root of 3. This is 10. This is 300. This is 5 square root of 5. 5 square root of 15. This is 25. And this is 100. Okay, let's start filling in this chart for 30, 60, 90. So if A is 6, A squared is 36. If B is 6 square root of 3, 6 square root of 3 squared, 6 squared is 36. Square root of 3 squared is 3. 36 times 3, let's see, that's 18, 108. To find C squared, 36 plus 108 is 144. To find just C, the hypotenuse, square root of 144 is 12. A is 10, A squared, 10 times 10 is 100. B squared is 300, but to find B, I need to take the square root of 300. Let's see, that's 2 and 150. That's 2 and 75. That's 3 and 25. That's 5 and 5. So groups of 2 of the same number. So I have a 2 and a 5 that come outside, and a 3 stays inside. 2 times 5 is 10. So 10 square root of 3. A squared plus B squared equals C squared. 100 plus 300 is 400. The square root of 400 is 20. So here, A squared. 5 times square root of 5 squared. 5 squared is 25. Square root of 5 squared is 5. 25 times 5 is 125. Then we have 5 times the square root of 15. All right, sorry for that little frame cut. I clicked on my computer to see if I was still filming, but my mouse was on like the record button, so when I clicked on it, it stopped recording. So we're going to go from where we left off. So we've just done 5 times square root of 5 is 125, or 5 times square root of 5 squared is 125. Now we're going to do 5 square root of 15. So 5 square root of 15 squared, 5 squared is 25. Square root of 15 squared is just 15. 25 times 15, let's see, divide by 4, so that should be 300 plus 75, so 375. 125 plus 375 is 500. Then we're going to take the square root of 500 to find just C. So this is 2 and 250. This is 2 and 125. This is 5 and 25, 5 and 5. There's a group of 2, there's a group of 2, and a 5 is left over. So 2 and a 5 come outside. 2 times 5 is 10. A 5 stays over inside, so 10 square root of 5. Let's see, a squared is 25, so square root of 25 is 5. I know that c squared is 100, and a squared plus b squared equals c squared. So 100 minus 25 gives me 75 for b squared. To find b is the square root of 75, which is 3 and 25, 5 and 5. There's a group of 2, a 3 stays in. So 5 square root of 3. Okay, and then the square root of 100 to find just c is 10. So now let's look at our pattern. Well, here a is 6, b is 6 square root of 3, c is 12. So here we're always going to say that the side across from 30 is our initial side. It's our unknown side. It's x. Well, how do I go from 6 to 12? I add 6 or I times by 2. How do I go from 10 to 20? Add 10 or times by 2. Notice that we multiply by 2 both times. That's our pattern. So go from A to C. So from the side across from 30 to the hypotenuse, you times by 2. 6 times 2 is 12. 10 times 20 is, or 10 times 2 is 20. 5 square root of 5 times 2. 5 times 2 is 10. Square root of 5. 5 times 2 is 10. So the hypotenuse on the 30, 60, 90 is double or 2 times the side across from 30. Now let's look at the side across from 60, right side B. Well, A is 6, B is 6 square root of 3. A is 10, 10 is square, or B is 10 square root of 3. A is 5, B is 5 square root of 3. We're multiplying by square root of 3 each time. 5 square root of 5 times square root of 3, 5 times 3, 15. So the side across from 60 is x. The side across from 30 times the square root of 3. That's your pattern. Okay. Now let's flip the page back over to the 45, 45, 90. We'll do those practice problems. And my mouse, is not on the record button in case I have to check. Or the trackpad. Okay, so we got this triangle here. This is 45, 45. This is 8. This is D. This is E. And then we have, this is, these are 45s. This is 9 squared to 2. And this is A, B, C. So this first one, right? The legs are equal because it's a 45, 45, 90. So D has to equal 8. Right? The legs are equal. E, if we look at our pattern, we take a leg and multiply by square root of 2. So 8 times square root of 2. That's it. There's your answer. Okay, don't put that in your calculator. It has to be exact. Over here, This leg, AB, is the same as this leg because it's a 45, 45, 90, so 9 square root of 2. And then CB, the hypotenuse, is a leg, 9 square root of 2 times square root of 2. Well, 2 times 2 is 4. The square root of 4 is 2, so 9 times 2. So 18. There's your answers. Let's do the next two. So let's see, I got this one, 45, 45, 90. This side is 5. This is B. This is C. And then we have this one, 45, 45, 90. Hypotenuse is 10. This is G. This is F. So let's look at the first one. So legs are equal in a 45, 45, 90. The legs are congruent. The measures are equal. So B has to equal 5. And then C is you take a leg and multiply by square root of 2. 5 square root of 2. You're done. Now save the best for last. We have the hypotenuse. So the legs are equal to each other, right? Their lengths. So F is equal to G. We just need to find out what those equal. Well, we have a hypotenuse is 10. In our pattern, hypotenuse is x squared root of 2. If I find x, then I know the side length. So they have to be equal. 10 is equal to x times the square root of 2. Right? Hypotenuse equals hypotenuse. Get x by itself, divide by square root of 2, divide by square root of 2. So 10 square root of 2. Now remember, this isn't simplified. You got to fully simplify. So to get rid of the radical in the denominator, you multiply the denominator by itself, square root of 2. Whatever you do to the denominator, you have to do to the numerator. 10 square root of 2 over square root of 4, right? 2 times 2. The square root of 4 is 2. 10 divided by 2 is 5. So 5 square root of 2. So this is 5 square root of 2. There's your answer. Okay, now let's do the practice problems for the 30, 60, 90. So we're going to flip the page back over. Okay, now we're using this pattern over here for 30, 60, 90. Let's see. 30, 60, 90. C, B, this is 5. And this one. 60, 30, 90. Let's see, this is G, this is F, this is 20. All right. So remember, the side across from 30 is our x side. We can use that side to find all the other three. So if the side across from 30 is 5, the side across from the side across from 90, the hypotenuse is 2 times this side. So 2 times 5, which is 10. The side across from 60, B, is the side across from 30 times square root of 3. There's your answers. Now over here, we have the hypotenuse. Remember, the hypotenuse is double the side from 30. So if I want to find the side of 30, across from 30, I divide by 2. 20 divided by 2 is 10. There's F. G, the side across from 60, is you take the side across from 30 and multiply by the square root of 3. There's your answer. Let's do the next two. And then we have okay, now let's look at this one. We have the side across from 60. Well, look at the side across from 60. The pattern is x times the square root of 3. So the side across from 60 should equal the side across from 60. So 12 should equal x square root of 3. Divide both sides by square root of 3 to get x by itself. So 12 over square root of 3. Rationalize the denominator, multiply it by itself. Whatever you do to the denominator, you have to do to the numerator. 12 divided by 3 is 4, so 4 square root of 3. So that means x, or the side across from 30, is 4 square root of 3. The hypotenuse is you take the side across from 30 times 2. 4 times 2 is 8, so 8 square root of 3. There's your answer. Over here, A and B. So the side across from 30 is 8. The hypotenuse is the side across from 30 times 2. So 8 times 2, 16 is B. And then the side across from 60 is the side across from 30 times square root of 3. So 8 square root of 3. There's your answer. We've got 2 more here. (60, 30, V, W, 5 square root of 3. (30, 60, 16). Okay, so this one over here, let's see. So we have a side across from 30. W is the hypotenuse. So to find this, the hypotenuse, you take the side across from 30 and multiply by 2. 5 times 2 is 10, so 10 square root of 3. And V. To find the side across from 60, you take the side across from 30, multiply by square root of 3. So 5 square root of 3 times square root of 3. Square root of 3 times square root of 3 is square root of 9. Square root of 9 is 3. 5 times 3 is 15. There are your answers. Over here, we have the hypotenuse. Oh, I forgot to label. This is B, A, C. So we have the hypotenuse. So if we find BA, the side across from 30 times 2 is the hypotenuse. So to go back, divide by 2. 16 divided by 2 is 8. And to find AC, we take the side across from 30 and multiply by square root of 3 to find the side across from 60. So 8 square root of 3. And there's your answer. Okay, so not too bad. Not a whole. It's nice because it's a pattern, so there's not a whole lot of arithmetic. The biggest thing I see every year, the biggest problem I see every year is students don't know their pattern. Okay, if you know your pattern, then these are easy. If you don't know your pattern, it's going to be impossible because you can't use Pythagorean theorem. On the test, we're only going to give you one side length. So you'll have 2 unknowns. It's impossible to use Pythagorean theorem then. Well, not impossible, but for where you're at in math, it's impossible. I'll just say that. But it's not impossible if you keep going with math. Now, 45, 45, 90 isn't too bad, right? Legs are equal. Hypotenuse is the leg times square root of 2. Not too bad. It should be pretty easy to remember. 30, 60, 90. The side across from 30 is our unknown side. The hypotenuse is double the side across from 30, so times 2. And the side across from 60 is the side across from 30 times square root of 3. Right? As always, I'm here every day after school, before school. If you need anything, just let me know. But that's the end of the video.